Today we're going to look at the applications of logarithms and exponentials. And let's look back to what we did in the first section. A equals PERT was a formula that you saw. Amount here ended up being your final amount. P, your principal, was your starting amount. So final amount equaled your starting amount times ERT. We want to expand this formula to be absolutely anything. So I'm going to rewrite this with just one thing different. A equals A sub 0 ERT. All this A sub 0 is saying is your starting amount. This can be the number of gnats in a house. This could be the amount of people in a town. This could be the amount of seashells on the seashore. We just want to know what the starting amount of something is. And this A sub 0 just is saying the amount when the time is equal to 0. So don't be confused by that notation. The A on the left-hand side of the equal sign is still the final amount. A sub 0 just says starting amount. And then when we use P, it's specifically the starting amount for money. So application number 1 is going to be how long will it take for something to occur that is compounded continuously. So in this case, how long will it take for your money to double? So assuming I got $7,500, which is my starting amount, that pays 6.75 compounded continuously, how long will it take to double? Well, I know I'm going to use my A equals PERT. And the way this problem is different from what we had before is now I'm solving for t in the exponent, which means I'm going to need to use my properties of logarithms to get t by itself. So assuming I got 7,500, that means my starting amount is 7,500. E is still there. The rate is 0.0675. T is what I'm solving for. And then my amount is going to be 15,000 because I'm doubling. Doubling 7,500 is 15,000. So then to solve for t, we need to get my expression with the t in it by itself. So we'll start by dividing both sides by 7,500. So 2 is equal to e raised to the 0.0675t. And now we can convert to logarithmic form. So the ln of 2 is equal to 0.0675t. And then divide both sides by 0.0675. Which gives me that t is approximately 10 years. Once again, at this step, you can convert to exponential form to logarithmic form. You could take natural logs. You could do log base e's. The way I got this ln of 2 is equal to 0.0675t is I said 2 is equal to the e 0.0675t. I know e can be rewritten with the natural log, and then my exponent is my answer. So that's really how I came about doing that problem.